Hi guys, welcome back to my YouTube channel, Mazatrol Tips and Tricks. If this is your first time here, my name is Phil, and I teach people how to set up and run a Mazak CNC lathe while programming it with Mazatrol. This next video idea was from a viewer suggestion. Dan was stuck on how to program this lathe part, and I was able to help him out. He suggested I make a video explaining the steps I took in creating his program. In this video, I'm going to show you guys how to program a roller using 4 different programming methods. 3 of the methods involving having some CAD geometry data points, and the last method is strictly programming the part at the machine with no help from a CAD program, which incidentally is the fastest and simplest method of all 4 examples. All right, let's get started. All right guys, here's our next program that we're going to be creating. This is a roller, and it's a diameter with a taper, a radius, and another taper, and it has 2 small radiuses in the corners here. So what I'm going to do is I'm going to show you the most common method that people would use to program this, which is describing every single feature on the part. So let's get started. So the first thing we're going to do is push the left button, go to Program, Program File, select a work number that's not listed up here. I'm going to select work number 50. So go back to Program, work number 50. And if it's a new program, push the Program button. Mazatrol. Workpiece material is aluminum. Max outside diameter of workpiece is 3.25 inches. Inside is 0. Workpiece length is 5 inches long. The max spindle limit, this is the G50 for the entire program. I don't want to run the chuck past 2,000 RPM. Finish allowance on X is 10 thousandths on the diameter. And finish allowance on Z is 5 thousandths. Stock removal of work face. This part is already cleaned up, and I'm just going to set Z off of the finished surface. So I'm going to leave this at 0. First thing we're going to do is turn on the coolant. M code, coolant on, down arrow. Now let's start programming this feature. So we're going to do with bar stock on the outside diameter. Cutting point on X is 3.25. Cutting point on Z is 0. And then we're going to do, let's just do auto for the speeds and feeds, but I'm going to change it to 8 thousandths feed rate and 50 thousandths depth of cut. I'm planning on running this with no coolant in just one tool. So I'm going to run it with a 35-degree diamond, which is tool 2. Offset 1, tool 2, offset 1. All right, here's our part. I have all of the intersect points drawn up in CAD, and I'm going to do it a line, radius, line, radius, line, radius, and line. So linear. Starting corner is 30 thousandths. Final point on X is 3 inches in diameter, and the final point on Z is going to be 9.268. So the next thing we're going to do is put a convex radius here. Continue. So that puts the start point here, and now the final point is going to be this intersection right here is 2.921 and 1.0617. And the radius for this is 250. Down arrow. And we're going to do a taper. Continue. Now the taper ends at 2.237 and 1.5954. So now the next thing we're going to do is do a concave radius, and we're going to give it this data point over here. So concave, push continue, 2.237, 2.4046, and the radius is 0.750. So now we're going to do a taper up this direction to this intersect point. Continue. 2.921 and 2.9383. So now what we need to do is do another concave radius to 3-inch diameter. So convex radius, continue, 3-inch, and 3.0732. And the radius is 0.250. So now what we need to do is do a linear three-inch diameter, and then we're going to go back 4 inches long. And then what we're going to do is do a chamfer at 3.25. So linear again, 30 thousandths, 3.25, and then 4.032 on the length. Down arrow, shape end, right button, figure check. And there's our part that we have drawn in there. So this is the most difficult way to draw this feature, is with every little single radius and line. You can do it, but it's not necessary on this machine. So now what we want to do is I'm going to create the same thing, and then it's going to overlay it on top of this. So what I'm going to do is I'm going to put this radius here as a tangent radius in the machine. So let's go bar out, 3.25, auto, and what we're going to do is draw a line over to here. So this is our print. So the intersect point between this horizontal and this taper is a 1-inch length. So linear, 30 thousandths chamfer, 3-inch diameter, and we're going to go back 1 inch to this intersect point. So now what we're going to do is do a taper and then put a radius in here, push radius, 0.250, push continue, and now we're going to put this intersect position down here, 2.237, and 1.5954. So now we're going to program this concave radius. So right here, concave, continue, 2.237 and 2.4046. And then the radius is 0.75. And we're going to do a taper from here to here. So the final point on X is 3 inches and 3 inches back on Z. And then we're going to do a horizontal line here, 3-inch diameter, 4 inches long, so linear. We're going to put a radius in here of 0.250. So that way it breaks this corner to a radius. 3 inches, 4 inches long, linear. So now right button, figure check. And there's no change in the graphics because it overwrote right on top of the existing one. So the first example used 8 lines of code. The second example used only 6 lines of code to give us what we want. So now I'll show you the third method. So bar out, 3.25, auto, so the first one is the horizontal line with the chamfer, so linear, 30 thousandths, 3 inches long, and we're going to go back 1 inch deep. So now we're going to do a taper, push the radius button, 0.250, and now push continue. And now on this taper, we're going to come down to this point here. So this is the intersect point of this angle and this angle with this tangent radius between them. And the bottom of that tangent radius is a 2-inch diameter. But the intersect position is actually lower at 1.7184. And it's 2 inches back. And down arrow. So now what we're going to do is do a line from here to here and then put this radius at the front of this line. So go taper, push radius, 0.750, push continue. Final point on X is 3 inches. Final point on Z is 3 inches. Down arrow, linear, radius, 250, and we're going to do this horizontal line here. And now we're going to break the edge. So linear, 0.030, 3.25, 4.032. Down arrow, shape in. So now this one is the least of our data points, and we only used one CAD point that we had to calculate instead of all of these CAD points that were required. So right button, figure check. So it's going to draw it 3 times on top of each other. So now what I'm going to do is I'm going to do it a 4th time. So now this is without any CAD information at all. So what I'm going to do is I'm going to erase all of this above it because this is all information we put in with a CAD drawing, and I want to do it right off of the print without any CAD data points. So right button, erase input. So we erase everything. So now we're going to do it without a CAD assistance. All right, now that I have it erased, now I'm going to program this part as if we don't have any CAD help at all. So here's our part. and we don't know the intersect points of anything here. So let's go bar stock, out, 3.25, auto, 8 thousandths feed rate, 50 thousandths depth of cut, linear, 30 thousandths chamfer, 3-inch diameter, 1-inch back, and the surface roughness is 6. I'm going to actually use this program to run the part. So next thing I want to do is do a taper. Radius, 0.250, push continue, and we're going to program a corner down here. So we're going to estimate this angle at a minus 35 degrees. The print doesn't actually specify the angle, I'm just eyeballing the print, and this is just to get me in the ballpark. I'm going to fine tune that angle as we go. So final point on X is question mark. Final point on Z is 2 inches. Taper angle is minus 35. Surface roughness is 6. Calculate. Now I'm going to do a taper with this radius in it as a tangent radius between this taper and this taper. So push continue and push radius 0.750. We're going to go back up here to 3-inch diameter and 3 inches long. So now what we're going to do is do a linear across to here, 3-inch diameter, 4 inches back, radius of 0.250. So now let's take a look at our part. So here's our part drawn up. So what I need to do is I need to put a horizontal line with extra geometry down here at a 2-inch diameter. I'm going to adjust this corner, this end point, until it falls tangent to this 2-inch line. The newer controls, like the T+ control, will calculate a radius with an angle, but this old T3 control will not do that. So this is how to do it on a T3, but this next step is not necessary on a T+ because it'll calculate that center position and that angle by giving it the center of that radius. So let's show you how to do it on a T3. So bar out, and I got to give it a tool, so tool 2, linear, and I need a diameter, 2-inch diameter. And I'm going to go back 4 inches back, shape in. So now we have some construction geometry at 2 inches diameter, and that's what the print shows that to be tangent to, right at the root of that radius. So let's zoom in on this area right here. So now we can see it's not tangent. So let's go ahead and correct the geometry. We already know what this intersect position is because we did calculate the CAD geometry already on the previous example, but we're going to just put numbers in here until it gives us a tangent point. So this is not the exact way to do it. This is get you real close. So this will get you within 5 thousandths. So final point on X, let's change that to 1.7. And then 1.7 here. Right button, figure check. So now it's a lot closer. We're going to zoom it in a little bit more. So 0.1 is the highest magnification on this older control. But we can still see a gap in it. So let's change it by 10 thousandths at a time, 1.710. Scale input. And we can see the line is still below it, but it's getting closer. So let's go another 10 thousandths, 1.720. Scale input. And now that looks like it's touching that line exactly. However, because we did calculate that point, that intersect position is 1.7184. So I'm going to move it 5 thousandths above this, 1.725. Right button, figure check. So this is only 5 thousandths different from the previous one, and we can clearly see a gap in there. So even though this is kind of a crude method to get the geometry, it's still within about 5 thousandths of actual geometry. So let's go back to the program, and let's type in the actual intersect position, 1.7184. And we'll see what it looks like. So with the perfect part, we can see with the pixel on the screen, one pixel is below it and the other ones are above it. So that's what this machine looks like with perfect geometry. So let's zoom out. So scale 1. And now we do not need this construction geometry, so we're going to erase it. So right button, erase input. Left button, program check. Scale input. And then push shape. So there's our part. So now we're going to do check continue. And we're nibbling at 50 thousandths depth of cut with the 35-degree diamond. Toolpath erase. And there we go. All right, from this point, let's set the work shift and let's run this part. All right, that looks pretty good. Program, file, Z offset teach, 0 input. We got our work shift set. So let's back off. So left button, go to position, auto, work number. Workpiece number is 50, input, and we're 1/10 behind our 0. Sometimes it's a 10th, sometimes it's 0. So today was a 10th. Let's go to the trace screen. We can see our 35-degree diamond turning tool touching the face of the workpiece. So let's back it off. And let's go ahead and run it. All right, auto, and we're gonna leave the coolant off. So let's go ahead and run it. And we're done. And there's our finished workpiece. If you guys like what you see, go ahead and push that subscribe button and click the bell so you won't miss any future videos we have coming out. If you guys found this video to be helpful, please give it a thumbs up. That helps my channel and helps YouTube share this video with more people. Also, if you guys have suggestions for future videos, please let me know down in the comments. Thanks again for watching.